Hello everyone, my name is Kevin Diaz and this is my final demo for my project for the Advanced Embedded Linux Development course on Coursera from CU Boulder. I have developed a door security system leveraging a servo as a lock, a magnetic contact switch as a door sensor to see whether it's open or closed, and a keypad for pin entry so you can lock and unlock with a known valid pin. This is a schematic that I have drawn up. It is not representative of the actual pin numbers, as this is a pocket beagle, not an actual BeagleBone Black. I was not able to find a BeagleBone Black to import into KiCad, but it gives you the general idea of how things are set up. You can see here that we are using 7 GPIO pins for the keypad, 1 GPIO pin for the contact switch with a pull-up resistor to ensure that it is high by default, and the motor servo, which is powered by an external power supply, which sets a 5 volts 2 amps with a capacitor to smooth out the current draw from the servo. And you can see that that is connected to the PWM pin on the BeagleBone. Here you can see the actual pin mapping that we have implemented in our device tree. That can be found here. You can see here that we are leveraging the matrix keypad driver from Linux and defining the pins inside of this driver. You can see we are setting the servo PWM pin here, and finally the magnetic contact switch. The magnetic contact switch is represented as a button as well, as if it was a keyboard button. So both the keypad and the door sensor leverage the libev functionality of the Linux kernel. We have also had to disable I2C, LCD, and the HDMI functionality on the BeagleBone to be able to have enough pins to be able to configure the keypad in a reasonable way where pins aren't all over the board, as well as just being able to actually just have enough GPIO pins that are available. You can see here that I had started an initial flowchart before I started working of what things should do. Essentially, you wait for an event. If something changes in terms of state, if the key is pressed on the keypad or the door state changes, something will happen. And that leads cleanly into a finite state machine. You can see here that I have defined a mealy state machine, drawn it out. We start in a state of locked as an assumption. Then we see, for example, if the pin is valid, and if the door is closed and the pin is valid, then we unlock the lock. And after a timeout of 15 seconds or whatever timeout you set, then the door will go back to this locked state. If the door is forced open, it is an alarm state. And the way we detect that is if the door is locked and the door is still open, which means that somebody potentially pried open the door. You can see that we have implemented this as a state transition table, and here you can see all of the different states, actions, and conditions for going to the next state. If we go to the project, we can see here that a release is generated here in an SWU format, which can be consumed by SW update, and we deploy that via Hawkbit here in the UI. And we simply just define a new software module, add it to a new distribution set as a new version, and send it to the BeagleBone Black. Some challenges we ran into were that device tree issue right here. This consumed a lot of time trying to figure out how to configure the device tree correctly and getting it read correctly. Other challenges included just configuring SW update. There was not a lot of good documentation on how to do that. And finally, understanding U-boot. We had to configure some patches in here in base external to be able to get U-boot to do certain things, such as setting a state variable, which SW update could leverage. We had to use the boot.cmd format since um.txt is now deprecated and not used by the BeagleBone Black, and that took a while to figure out as well. Ultimately, I did a lot of learning on how to use ePOL, device tree modification, implementing the finite state machine. I've never done that before. Getting the OTA updates and just getting this release to work. This is on a GitHub CI/CD pipeline. Additionally, the CI/CD pipeline also publishes docs to my GitHub page. So I can look here at the test coverage. You can see that's 100% coverage for unit test. And we have technical documentation via Doxygen. So we can go in here and look at a file. So for example, if I go to doorsensor.c, I can look at the dependencies, look at the functions, and look at all of the documentation around the parameters and such. So here's the actual device itself. You can see here I have my BeagleBone Black wired up to our magnetic contact switch, our keypad, and our servo. The servo is wired up with power from my 5-volt external power supply. And then we have 3.3 volts feeding the keypad and the contact switch. You can see here what we saw in the schematic a little bit, the pull-up resistor, capacitor to smooth out the power from the servo. And yeah, so here we have the servo state unlocked initially. And that is the initial state because you need to be able to lock the door at first. I can then close the switch, which means the door is closed. And you can see that automatically the door has been closed. Then I come in and I enter my pin code, 1, 2, 3, 4, enter, and you can see that the door has unlocked. And now that it's unlocked, after a certain timer of 15 seconds, it will go ahead and relock because the door is still closed. If I had left this open, the door would remain unlocked. And let's see it lock here. There we go. The timer has expired and the door is now locked.